In this module, I demonstrate the calculation of the yield to maturity on a bond using a finance calculator. The calculator being used is the Texas Instruments BA2 Plus in the emulator mode. Other finance calculators can be used as well, but this is what I'm using currently. Yield to maturity is the rate of return earned on a bond held to maturity. It's also sometimes called the promised yield. The rate of return investors expect to earn if they buy a bond at a specific price and hold it until maturity. Bond prices, they constantly fluctuate over their lives due to external forces and the passage of time. And so the yield to maturity is a combination of the return that accrues to the holder of the bond, both from the stream of payments and also the valuation of the bond when they terminate their holdings. This particular formulation is the basis of the YTM calculation. INT is the periodic interest rate or the coupon rate in dollar amounts that is to be discounted and accrues to the bondholder. M is the terminal value of the bond, also called the face value of the par value of the bond. VB is the current price of the bond or the price that the investor paid to hold that bond. YTM is the variable that we are looking for, and T is the time period and the duration for which the bond is held. What is the yield to maturity on a 10-year 9% annual coupon which has a $1,000 par value that sells for $887? So $887 is VB, 1,000 is FV, T is 10 or N is 10, and T is like 1, 2, 3, 4, goes up to 10. And INT is actually not 9 but $90, which is 9% off 1,000. So 9% of 1,000 is $90. And so this is your interest stream, and your final cash flow is the sum of your interest stream and the par value of the bond. So that's $1,090. Now these have to be discounted, and the sum of these should be equal to the sum of the present value of these future cash flows should be equal to 887, which is the current price of the bond. So the missing variable is RD, which is the yield to maturity. Find the RD that will work. What does work mean? Means the discount rate that will exactly equal the present value of all of these cash flows to 887. For that, we use the calculator. Additional setup. I just want to show you the fundamentals of this before just punching in the numbers. So you want to discount your interest payments using the discount factor. So it's $90 divided by 1 plus RD to the power 1. So this is T here. 90 divided by 1 plus RD, and here's T max, which is 10. And for the 10th payment, for the 10th year, we actually have an additional cash flow, which is $1,000, the face value of the bond, and so we have to include that in the equation as well. So notice we have everything in numbers except for RD, which is your yield to maturity. Now if you try to do it the longhand way, this is actually a polynomial of nth order, and that'll be very complex and difficult to solve. So that's where the calculator comes in, and that's why I have a calculator module on how to calculate the yield to maturity. So let's enter these numbers in the time value of money fields. There are 5 of them. N is the maturity period or the maximum time on a bond. IY is the interest rate per period. PV is the current price of the bond. PMT is the interest amount that accrues from the bond, and it's calculated via the coupon rate. This is a dollar amount. Sometimes students make a mistake. They'll enter, like in this case, they would enter 9 as opposed to 90. So PMT is a dollar amount, okay? It's a payment. So a percentage cannot be a payment. So you have to convert that to a dollar amount. And FV is the par value of the bond. So N equals 10. So do 10 hit N. The current price of the bond is 887 with a negative. That's present value. Notice I skipped IY because this is our variable. We're going to come to it later on. PMT is 9% of 1,000. That's $90. It's PMT. The future value is 1,000. Now we know that these values have been accepted by the calculator when you see the little triangle at the top right. If you don't see that, that means you just entered it on the keypad, but you actually forgot to hit the enter button. So you have to make that change then. In this case, we are good. By the way, if some of you do not like 4 decimals, how do you change that? You change that using second format. So second format. In this case, dec, that's decimals is 4. You can change that to whatever you desire, 3, 2, 1. I'll change it to 2. That hit enter. And to clear this, hit the clear button here. Clear. And we have our values actually already stored. Let's hit compute IY to get the yield to maturity. Compute IY, and that's 10.91%, which is exactly what we have here, 10.91%. You can actually also, revisit the values that you entered to get to 10.91. So for that you do compute N, and so it's a 10-year bond. Compute PV, the current price of the bond is 887. Negative simply indicates that you have to invest in a bond, so your cash flow is negative. Compute payment, that's $90. Remember the $90 associates with the percentage. The $90 here is associated with the 9% annual coupon. And so just keep that in mind. I know I'm repeating myself, but a lot of students, especially in a rush, under exam pressure or something, they'll put 9, which will be accepted by the calculator, but it'll result in a wrong output. And compute FV is $1,000. So anyway, the objective of this exercise was to show the calculation of the yield to maturity for a bond. This is Pank Agrawal, PhD Finance, giving you a tutorial on this topic.